Chapter 6, Lesson 14, and our title of our lesson is Divide Decimals by Powers of 10. Let's see, nod your head if you remember. Last week, we did a lesson called Multiply Decimals by Powers of 10. Yes. Okay, so last week, we did a lesson that's very similar to this lesson where anytime a decimal is multiplied by something like 10 or 100 or 1,000, it told us how many times we could move the decimal point forward in the answer. So when you divide, you do the same thing, except you move that decimal point backwards instead of forwards. So when you divide the decimal, you move the decimal point backwards instead of moving it forwards like you do when you multiply. That's what we're doing in today's lesson. So it's very similar to what we did a few days ago when we were talking about multiplying. So let's look at the problem of the day. It says, at a store, the daily newspaper costs 75 cents every day except Sunday. The Sunday paper is $2.50. A subscription costs $5 per week. How much does a weekly subscription save in a 20-week period? So if you bought a newspaper every day, it would cost 75 cents a day for the newspapers from Monday through Saturday, and then on Sunday the paper costs $2.50. So you'd have to add up how much it costs, or use multiplication maybe, and then addition, to figure out how much it would cost for 1 week of a subscription. Then you'd multiply that by 20, right, to see how much a 20-week subscription would cost. And then if you pay a flat $5 a week, you can get a subscription to the newspaper as well. So a subscription means that you're going to renew it and you're going to pay for it every single week. And if you didn't have a subscription to the paper, but you went to the newspaper stand and you bought a newspaper each day, you're going to see how much the difference in price would be between a subscription and if you just went and bought the newspaper each day. So the key here is that it's over a 20-week period, not just in 1 week, but over 20 weeks. How much would you save? Okay, so use your whiteboard if you have a whiteboard. If you don't have a whiteboard, just use the top of your notes for today to work out this problem. I'll give you a couple minutes. Try it by yourself first, and then you'll be able to share what you've got with a neighbor. Okay, first by yourself. I'm going to show you how I would work it out. So there's 7 days in a week. 6 of the days, the newspaper cost 75 cents. So I'm going to multiply by 6. Something else you could have done was just add 75 cents 6 times. You could do that. I'm just going to use multiplication to solve that one. So that's 30. There's 42 plus 3 more is 45. Then the 7th day, the paper costs $2.50 because that's the Sunday paper. So my total cost for the week is, if I went and just bought a newspaper every single day, would cost me $7 during the week. Now, the first thing I can do, this is where you could do a couple of different ways. So one way is that I can see how much it would cost me over 20 weeks. So $7 times 20, we know that was going to happen. Hold on a second. I don't know what's going on. Hold on. There we go. Well, that was weird. That's even weirder than other times. Okay, so we have 20 times 7. $7 times 20 weeks would be $140.
Oh my.
Okay.
5 and 20.
So, hold on, listen. Here's the other way, or the rest of it. That would be if I bought a paper every day, then over 20 weeks, I would spend $140 on newspapers. If I paid $5 a week for 20 weeks, I would pay $100 a week. If I subtract those, because it's how much does it save, so we're trying to find the difference, would be $40. So the other way that you could have gone with that was buying the paper separately costs $7 a week, and having a subscription costs $5 a week, and that's a difference of $2 a week. So you could have done $2 a week times that by 20, which would give you $40 a week. So if you found the savings for 1 week, which is $2, and you multiply that by 20, which is the 20-week time period, then you could have gotten $40 as well. So that was how you could have done it. Gone a couple of different routes on that one and still got the same answer.
I got the grade spell. We went for the subscription. I thought the giveaway.
Oh, you read it wrong. Okay. All right. Eyes up on the screen. I have to wait for your side conversations to come to a close before I can finish working on math. It's important that you're not whispering or talking with the people that you're sitting by. Remember, we need your full and 100% attention during math time so that you understand what we're doing. Okay, so this is our last lesson in chapter 6. So that means that tomorrow and the next day we're going to be reviewing. We're going to review multiplying decimals. This was a big chapter. It had a lot of stuff in it. Multiplying decimals, and then we're going to review dividing decimals on Thursday, and then we're going to take the test on Friday. So the test will have multiplying with decimals, and it will have dividing with decimals. So we have to remember, like, I feel, and you probably feel the same way, that when we did multiplying decimals, it was a really long time ago, but it was part of this chapter. So we have done a couple of quizzes in between that hopefully help to remind you, and we'll be doing lots of review over the next couple of days to make sure you're ready for that test on Friday. But this is the last new lesson. So we're going to talk today again about how multiplying and dividing decimals is similar to multiplying and dividing with whole numbers. Now in your notes, I need you to write divide decimals by powers of 10. That's an O. So the question at the top of the page is the patterns. What are the patterns that you see when you divide decimals by 10, 100, or 1000? So when we multiply decimals by 10, 100, or 1000, we noticed a pattern also, right? And so here was the pattern that we noticed, and I want you to write this one down in this lesson as well, even though we've talked about this before. So if you see something like 10 to the first power, it's the same thing as 10, which would mean you would move your decimal one space. If you see 10 to the second power, it's the same thing as 100. I know, I want you to write it one more time in this one. And that's the same thing as moving the decimal two spaces. If you see 10 to the third power, that would be 1000, and that would be moving the decimal three spaces. But the difference is that we have to decide, and like on the math test on Friday, you're going to have to decide whether or not you're going to move the decimal forward or backwards. So this is what I want you to write just so you can remember for yourself. We're going to move decimal forward when we multiply, and we're going to move the decimal backwards when we divide. So draw yourself that little chart with the arrows so that when you're working, especially over like the next couple of days when we do review, because when we do review, it's all mixed review. So it's going to be, there may be a couple that have multiplication, and then a couple with division, and then another with multiplication, and then 5 more with division. So they're all mixed up. So you have to really pay close attention to the sign. If you move the decimal the wrong direction, your answer will be incorrect. Right? We've learned that when the decimal's in the wrong spot, the answer is not right. So we have to make sure that we move the decimal the right way, forward or backwards. Forwards for multiplying, backwards for dividing. So if you have this question, I'm going to give you a question really quick. 2 73/100, and you divide that number by 10. I want you to write what you think the answer would be based on what we just talked about. Anybody have a guess on what they think it might be? Nolan, what do you think?
273,000.
Because I take this decimal and I scoot it backwards one space. So I would add a 0 in front of the decimal.
That or you move the numbers.
Now let's talk about scooting the decimal. Here's another one.
There's the song.
Wait, but wouldn't the 3 be a remainder?
Oh, no. There's no remainders here. Wait, hold on. Freeze. This is a shortcut method. I still hear people's voices. Shh. I want you to be able to hear what I'm saying. If your neighbor has something really good that they want to tell you about this math lesson, let them wait until I'm finished. And then if they have something they want to try to help you with, then they can do that during independent practice. But for right now, I want you to make sure you hear everything I say so that everyone around you can hear too. So this was, if you look back in your notes a few lessons ago, when we did multiplying by powers of 10. And we said that if the number is a 10, that tells you that you move the decimal one space. And when we did multiplying, we went one space forward. Now that we're dividing, we go one space backwards. It's the same as the multiply by powers of 10 lesson. The difference is that instead of going forwards, you're going backwards. This number has 2 zeros on it. So because that number has 2 zeros, you're going to take the decimal and you're going to move it backwards 2 spaces. 1, 2. Any empty space I've created would be filled with a 0. So then I put a 0 at the front. 58,000.
That's kind of makes sense.
Oh, I wasn't here for the power.
There you go. That's why you're confused. So keep watching because we're not finished.
Well, you heard the song this morning.
That's not what we're doing right here though.
Okay.
So if I have 16 and 2 tenths,
Don't give me the
Yeah, but that's good.
too many voices. Too many voices. 16 and 2 tenths divided by 10 to the third power, just like what we wrote on the side, we wrote 10 to the third power is the same thing as 1,000. And you would move it 3 spaces. So it's you're either looking at how many zeros the number has on it, or you're looking at the exponent if it has an exponent. So this is what you do. 1, 2, 3. The spaces that I've created would be filled with a 0. So there's my answer. Vicky, I need you to turn and face the screen, please. Andrea is not your teacher right now. I am, so you need to make sure you're facing the screen, not her. So let me go back to the first question, because I wanted to show you something. What I'm showing you is a shortcut to working out these problems, because some things, I know, I said I'm going to go back to this problem for a second. Some things can be worked out in your head as mental math. Powers of 10, if I were, okay, Bryson, listen to this. What if I multiplied 67 times 10? I can do 67 times 10 in my head mentally by just adding a 0 to the end of 67, right? So that's a trick for multiplying by powers of 10. So there's also a trick for multiplying and dividing decimals when there's powers of 10. So what this really means is you could do it like this. Okay, I could bump the decimal point up into the answer. Hold on. 2 and 73/100 divided by 10. I could bump the decimal into the answer. 10 doesn't go into 2. 10 goes into 27 twice. That equals 20. Get a 7. Bring down the 3. 10 goes into 73. Man, I am not touching the button, I promise.
I trust you.
Thank you.
I'm only by 1. Divided by 1.
But then it's the same.
Watch. I guess you gotta redo this part that I had to erase. Now 10 into 73 goes 7 times. Ugh.
Oh my gosh.
Glitch. Can you just do paper?
Let's hope maybe it's the button on my shirt. So I pulled up my sleeves. We'll try it now.
Hurry up, you have to go faster.
Then we said, keep watching. Girls, keep watching. Then we said you would add a 0.
Yes!
Then you'd bring down the 0.
Yes!
And then 10 goes into 33 times.
Yes! Hit the B, hit the
Oh,
B.
you didn't bring down the 0. There's no 0 in that one. What?
270.
You can annex.
I wasn't here.
Listen. I don't know what's happening with this pen. You can annex a 0 anytime you want and it does not change the value of the number. That has gone for like the last 4 lessons that we've done.
Okay,
So
then why don't we just change it to 0?
you do. You do.
You could do it all the time and it wouldn't.
Yes. The answer is yes.
But you can't put it in front of
On the end of a number that has a decimal in it, you may put a 0 and it does not change the value of the number. So yes. So the last like 3 lessons that we've done, anytime that you ended with a remainder as your answer, you're supposed to annex a 0 and then drop it down and continue the problem until you have an answer with no remainder. We've already just established that. So what I was trying to show you before this thing started glitching out is that you get the same answer. You get the same answer. If you want to work it out like this, you'd get the same answer. Watch. Oh, except don't forget the decimal point. So the decimal point would go right there. So the way I just showed you with the shortcut looked like this. Bryson, make sure you watch this. So all I said was you would take the decimal point and you would scoot it back 1 space. Do you see these 2 answers? They both match. So the trick is when you're multiplying with the power of 10, you would move the decimal place forward either the number of zeros that are in the number or the number that the exponent tells you to. If you're if you could, sure. If you would like to do this on each of these problems, you can. Sure. I'm showing you that you can get the same answer. What I'm telling you in today's lesson, I just want you to open your mind for a moment.
Do that without the 0. Or would have a remainder.
There's no remainder.
There would
I'm
be,
not sure of what your
it's 0.
Yes. You can't have a remainder when you're talking about decimals. You shouldn't have a remainder. So what you do is you put a 0 at the end of the number and then you continue the number. I'm going to talk to you about annexing zeros as soon as I'm finished with the rest of this lesson. Because if you were not here that day, I want you to know about it, but everybody else already heard about it. And now we're getting back to, we're talking about a lesson that happened a long time ago. That I wish that you would have told me that you didn't know because we've used it every day since then. And if you weren't here for that one day, then you need to make sure you knew what we did because you missed what we did since then. Because if you have remainders on any of your answers, then they'd be wrong.
I do.
Okay, so today's lesson, all you have to do is take the decimal point and scoot it backwards, the number of zeros that you see in the number. So I was trying to show you that you can get the answer also by just dividing, but it takes a lot longer. So there's some things that you can do in your head mentally because it's a power of 10, and it only works because it's a 10 or 100 or 1,000. So this is one of those tools for your tool belt that you can't use all the time. You can't use it all the time. You can use it only when it works because it's a 10 that you're dividing by. It doesn't work if you're dividing by another number. It only works if you're dividing by 10. So I want you to try these 3. Try these 3 in your notes. Put them in your notes somewhere that I want you to write them down. Wait, I don't want you to talk to anyone. I just want you to try to solve these 3.
Oh, that's easy. She's known this.
Here's my number. I'm going to rewrite it bigger over here. 315 and 2/10. Since I'm dividing, which is what I told you to make sure you pay attention to. Because on the test, you're going to have mixed questions. Some will be division, some will be multiplication, and you have to know which way to move that decimal point. You only move it backwards if you're dividing. So I take my decimal, and since the number I'm dividing by is 10, and 10 has 1 0 on it, I'm going to scoot my decimal point back 1 space. Just like that. So then my answer is 31 and 52 hundredths. For the second one, I have the same number, 315 and 2/10. But this time, the difference is that I'm dividing by 100, which means I move my decimal 2 spaces backwards. So now I take it from here and go 1, 2, and now I have 3 and 152 thousandths. Last one, I'm dividing by 1,000. I have the same number, This time I'm going to go 3 spaces. 1, 2, 3. I go 3 because that number is 1,000, and 1,000 has 3 zeros in it. So now I have that's my answer. I put a 0 at the front because anytime you have nothing up before the decimal, you should put a 0 there to show that there's nothing. These ones I didn't because there was a digit there. No, I want you to put a 0 at the beginning. That's what I just said. You need to have a 0 at the beginning. Here's why. You're never going to see it on a test written that way. Never. It's always going to have a 0 there. And if you get in a habit of writing it like that without the 0, then you're not really showing what number is in that place there. You should show a 0 at the beginning. That's really the proper way to do it. If you don't do it that way, once you see it on a test, it's going to make it confusing. Look at your example number 1. Good. Three, 2, 1, 0. Example number 1. Boys. Thank you. Laura needs to make up 10 payments to pay for her motorized scooter. How much will each payment be? Waiting for the sharpener. Waiting for the voices. Nolan, that's your voice that I'm waiting for. How much will each payment be if the scooter costs $219.50? So, here's what I tried to just show you on one of those last examples. There's 2 ways to solve these problems. One way is to divide, and you can divide that by 10 into $219.50. You can do that if you want to, and you would get $21.95. So each of her payments would be $21.95. The other way, that's over here, shows that you can divide a decimal by 10. When you divide a decimal by 10, you move the decimal point 1 place backwards to the left. So instead of $219.50, you take the decimal point and you scoot it back 1 space. So your answer is still $21.95. On this page, it's just showing you that there's 2 ways to solve the same problem. If scooting the decimal point doesn't make sense to you and it's not something that you want to do, then you can do it the long way and do the division here. It's up to you. This is just, there's not that many problems out there when you're talking about division or multiplication really with decimals that you could do easily in your head. And this is one type, is when you're dividing or when you're multiplying or dividing by powers of 10. This makes it super easy that you could just scoot the decimal and you're done. There's no work to show. Okay, so this page just shows you there's 2 ways to do it. So you could check by using multiplication. So if I multiplied $21.95 by 10, I would get $219.50. So you could solve by using, or check your answer, your solution, by using multiplication since it's a division problem. Look at example number 2. It says, in the past 10 to the 2nd power years, scientists measure the movement of the continents to be 190 and 5/10 centimeters. If the continents move the same amount each year, how much did they move in just 1 year? So we're doing division. This part right here is something that's important for you to know, and we did write that in our notes. If you have 10 to the power of 2, that's equal to 100, which means you would move your decimal 2 spaces. You could solve it that way. That's going to probably be on the next screen. The other way is right here. You could just divide it. And, Bryson, what they did here was when they got a remainder down here of 5, they started annexing a 0. So they put a 0 here and brought it down and then said, well, 100 still doesn't fit into 50. So then they annexed a second 0, and 100 fits into 500 5 times. It gives you a more precise answer. When you're talking about decimals, you can't have a remainder. Now the trick saves you from doing any of that stuff, because if you have 190 and 5/10, and you're going to divide it by 100, all you have to do is that. Now you have 1 and 905 thousandths. Thank you. The helpful hint. The quotient of a number and a power of 10 that's greater than 1 will always be less than the original number. Did you hear that? No? No? Let me read it again. The quotient of a number and a power of 10 that's greater than 1 will always be less than the original number. So this number here was 190 and 5/10. That's greater than 1, right? It's 190 is on that side of the decimal point. So anytime, because we're dividing, remember? So we're taking 190 and we're dividing it by 100. That's what we're doing. 190 and 5/10, and we divided it by 100. So that's why we ended up with just 1 and 905 thousandths. So you should be thinking about, remember when you're dividing, you make numbers smaller, right? You make them all smaller pieces. So when you're dividing the numbers, you're going to make the numbers smaller. You should be remembering that. So here's the trick that I just wrote on the bottom of the other page. You could move the decimal this time 2 spaces backwards. So you get 1 and 905 thousandths. So the continents moved 1 and 905 thousandths centimeters in 1 year. And you could use multiplication to check your answer. So if you went 2 spaces the other way and you multiplied it, you'd get 190 and 5/10, back to where you started. Multiplication and division are, they're opposite of each other, they're inverse. So you could do the opposite thing and get the same answer. That's why we use it to check our answers. Let's look at the guided practice for a minute. 7 and 2/10 divided by 10. How many times will I move the decimal point?
Once.
Once. Why once, Malachi?
Because it says it's 1 0, that means you move it once.
You guys hear that? Girls, pay attention. There's only 1 0 on 10, so because there's only 1 0, you just move the decimal once. So I take this decimal and I scoot it backwards 1 space, put a 0 at the beginning, and now I have 72 hundredths as my answer. 21 and 5/10. Divided by 10 to the second power. Angelina, how many times will I move the decimal? 2 times, and how do you know it's 2 times? Because the power of 2 tells you, right? So because it's a power of 2, you scoot the decimal backwards 2 spaces. So now I have 215 thousandths. What about 19 and 2/10? And I'm dividing it by 10 to the third power. Amelia, how many times do I scoot the decimal point backwards? Okay, hold on. 3 times, and why do you say 3? 3 because she said it a different way than Angelina said it. It could be like what Angelina had said already, is because it's to the power of 3, you scoot it 3. Amelia says because 10 to the third power is really equal to 1,000. Because then that's how many zeros it has. 1, 2, 3. So anytime you create some space, you have to add a 0 into it. Okay, Amelia, what is your question now? You should do it on a few of the questions. You don't have to do it on all. As long as you're getting them right, then you don't have to do it on all of them. Wait, hold on. Let me rephrase that. Watch. If I have this as my answer, and I want to check by using multiplication, if that's my answer and I'm multiplying it now by 10, all I do is go like that. Okay, 7 and 2/10. That's what I started with. It's not really working out. The problem is just moving the decimal back the other direction, because now it's the inverse operation. Okay, so now I check guided practice with you. So now you should start your independent practice. Bryson and I are going to have a conversation about annexing zeros so that he can understand. Anybody else want to talk about annexing zeros? If you do, meet me at the table with Bryson, because that's what we're going to be talking about. If you don't understand why you annex a 0, that's what we're going to have to talk about.